troubleshooting of pneumatic systems. Let us discuss on safety precautions on pneumatic systems. When other conventional energy sources are thought to be dangerous, pneumatic systems are frequently used. Commonly, pneumatic tools and equipment are employed in place of high voltage electricity and combustible liquids. People can suffer serious harm from compressed air. Never allow compressed air enter a human cavity such as the nose or ear, and never shower anybody with it. Oil droplets and other pollutants in the compressed air that is emitted through the exhaust can harm the eyes and respiratory system. The entire circuit should be checked for any potential loose pieces, broken pipes, or abnormal pressure before turning on any systems. Work should be stopped right away if a system leak is discovered. While compressed air is still running through your system, avoid making any alterations, big or small. First, turn it off. To prevent attachments from being ejected during tool operation, always employ a safety clip or retainer. To avoid accidental disconnection while in use, make sure that all hose connections are fastened with positive locking mechanisms. Use air compressions away from combustible objects in a well-ventilated location. Avoid placing anything that can obstruct airflow on or against the air compressor. Never use a pneumatic tool at a pressure higher than the manufacturer's recommendation. Use connections and hoses with PSI ratings that are equal to or higher than the air compressor's maximum pressure. The shut-off valve for compressed air should always be accessible and visible. Never point any portion of the body, including other individuals, at a pneumatic tool or nozzle. Use just the attachments that the tool's manufacturer suggests you use with it. Maintain pneumatic tools as directed by the manufacturer, including cleaning, lubrication, and general upkeep. A pneumatic tool should never be carried by its hose. Only grounded outlets should be used to plug in air compressors. See number 2. Basic pneumatic system maintenance and troubleshooting. Once in a week. Drain compressor, tank, filter, bowl, and any airlines that have drain cocks. Check compressor crankcase oil level. Check compressor safety relief valve. Once in a month. Inspect discharge air filter. Check pressure reducing valve setting. Once in every 3 months. Change crankcase oil. Oil the compressor motor. Check compressor pressure switches. Once in every 6 months. Check for moisture, oil, and dirt in airlines. Clean the intake air filter, felt, and screw types. Check the compressor belt. Check the pressure relief valves. Check calibration, operation, nozzles, and restrictors of transmit temperature controllers, pressure controllers, thermostats, and humidistats. Check piping of pressure transmitters and controllers. Clean elements and humidistats. Once in year. Replace cartridge type intake air filters. Check calibration of receiver controllers. Check valves for tight close-off. Troubleshooting pneumatic system. Low operating pressure. For a pneumatic system to operate well, adequate air pressure is necessary. System problems are significantly exacerbated by air pressure problems which have a variety of root causes. While the compressor is frequently the cause of air pressure loss, other factors such as loose valves and connections, filthy filters, and poor maintenance practices can also contribute. However, problems with either too low or too high a pressure will affect the system's overall effectiveness and running expenses. When there is inconsistent or no airflow, the intake filter may experience pressure problems. The intake becomes clogged if the filter is rusted or broken. Simply remove the intake filter, clean it, or replace it to solve the problem. If the system is underpowered or the machine isn't working, you most certainly have a leak someplace. Using an aerosol sprayer that can be filled with soapy water or light oil is the most effective approach to identify leaks. Spray liquid down the length of the hose starting at one end. If there are leaks in the hoses or attachment, bubbles will form where the two come together. Bubbles indicate air leaving. Low air quality. Components on the demand side such as pressure valves, flow control valves, and linear or rotary actuators are impacted by air quality. On certain parts, poor air quality can have a cascading effect on the entire system. Severe rust is evident on the pistons. If there is even the slightest indication of corrosion, there is a moisture issue. A pneumatic system can suffer severe damage from moisture, which can enter a system in a number of ways. Prolonged moisture exposure causes corrosion, which spreads to the other system components and causes a variety of issues throughout the entire system. One of the most frequent issues with pneumatic systems is valve spool jamming, which is typically brought on by corrosion or system debris, which can make a valve stick and not open properly. By changing clogged filters and doing routine maintenance on your machine, you may prevent valve spool jamming. Poor electrical system. The system won't function properly and could be harmed if the voltage is unstable, out of the operational range, or both. Important information. Make sure the power is off and that there is no air flowing through the equipment before checking voltage or power difficulties. Atmospheric condition. Deformation and misalignment. Metal expands and contracts at different temperatures as it is heated up. Metal parts may get misaligned or distorted as a result of the expanding contracting cycle, which will reduce the system's overall efficiency. Make sure to keep your compressor away from sudden temperature changes and pay attention to the outside temperature when working with your system to prevent these problems. Pneumatic installations. Any pneumatic system, no matter how good it is, will fail prematurely due to inadequate installation. Side loading, which happens when a load is applied to the piston rod without support or guidance, or when the mounting and piston rod connection are out of alignment, can result from improper mounting. Pneumatic cylinder repairs, for instance, will be required if side loading develops. There are numerous strategies to reduce side stresses, but nothing beats accurate alignment during first installation. Selection criteria. It can be difficult to choose the right pneumatic system for your particular application, from selecting the correct directional force required to figuring out the load requirement for your specific process, and it's easy to choose the wrong product despite the fact that pneumatic systems are simple in design, easy to install, affordable in price, and durable in terms of performance.
I hope after watching this video, you can know the safety aspects, maintain them, and troubleshoot the pneumatic and hydraulic systems. Thank you for watching. Have a wonderful day.
Hello. Welcome to the session on dismantling, overhauling, and assembling cross-slide and hand slide of the lathe carriage. Let us look at the objectives of this session. At the end of the session, you will be able to dismantle the compound rest from the cross side, remove the carriage unit from the machine bed, assemble and test for functions. The required tools and materials are lathe machine, spanners, tap wrench, Allen key, kerosene, bunion cloth, lubricating oil, torque wrench, cleaning brush, safety goggles, gloves. In order to dismantle lathe carriage from lathe machine, turn off the power supply to prevent accidental startup. Then, unscrew the tool post locking handle and remove the tool post from the compound slide. Before removing the feed screw handle, examine the handle and its surroundings for obstructions or debris. Then, rotate the feed screw handle of the top slide in an anti-clockwise direction to get it released from the dovetails of the compound slide. Now, take out the jib from the dovetail of the top side. Unscrew both the clamping nuts from the T-bolts provided on the swivel base of the compound slide and take out the unit. Remove the taper pin to remove the graduated collar of the compound slide. Take out the jib strip from the dovetails of the cross slide so that it can be made to slide out easily. Once the taper pin is removed, inspect for any sign of damage or deformation. If the pin is damaged, replace it with a new one. Now, disengage the lead screw from the cross slide. Then, unscrew the lock nuts from the cross slide feed screw to remove the graduated collar. Now, unscrew and remove the saddle clamp. Then, slide away the tailstock unit and take it out of the bed. Similarly, slide away the saddle unit towards the right end to take it out of the machine bed. Clean the parts thoroughly with kerosene oil. Then, wipe them with bunion cloth and keep the parts in tray. Now, visually inspect the components for damage and wear. Then, lubricate the parts with lubricating oil. Once all the parts are lubricated, reassemble the saddle by lowering the saddle onto the lathe bed. Then, insert and tighten the saddle mounting bolts securely. Then, insert and tighten the tailstock unit onto the lathe bed. Reassemble the saddle clamp and test the saddle's movement to ensure it slides smoothly. Then, install the jib strip and test the movement of the carriage to ensure it slides smoothly. Once dovetail is assembled, fit feed screw handle by simply screwing it back. Ensure all the handles are securely tightened, but avoid over-tightening. Once all the parts are reassembled, turn on the power supply. Finally, check the function of the lathe carriage. Let's recap the key points discussed. Dismantle the lathe carriage by removing the tool post from the compound slide. Once the saddle clamp is removed, slide away to remove tailstock unit and saddle unit in sequence. Clean the dismantled parts using kerosene oil and inspect for damage and wear. After lubricating the parts, assemble them in reverse sequence and check the function. This brings us to the end of the session. Hope you have gained a good understanding about dismantling, overhauling, and assembling cross slide and hand slide of the lathe carriage. See you in the next session.
Hi students, today we are going to learn about types of inspection and gadgets for inspection. We are first going to learn about the inspection.
Inspection is necessary for any machine, equipment where remarkable risk to health and safety may arise from wrong installations, reinstallation, or any other circumstances. The purpose of inspection is to find whether machine can be operated, adjusted, and maintained safely. The need for inspection and inspection intervals is to be determined through risk assessment. The summary of inspection should be recorded and same should be kept at least until the next inspection of that machine. Machine equipment that required inspection should not be used unless the machine has been inspected. If the machine equipment obtained from any other source, once should be ensured that physical evidence of last inspection is accompanied with the machine, such as inspection report, some form of tagging, labeling system, or color coding. One of the most important documents that can help with inspection is the manual. Manual is one of the integral and necessary literary part that the operator has to know before handling and operating the machine. It will be provided by the manufacturer along with the supply of the machine. Manual furnish All information about the machine like size of the machine, foundation and erection method, safety procedure to be followed, operating procedure and periodical maintenance required. The machine manual will also provide about the required power supply, safety procedures, grade of lubrication oil to be used, etc. Availability of suitable spare parts and details of the dealer supplier has to be provided in the manual. Otherwise, use of any other parts will not suit and the machine will get damaged. We have to refer and follow manual if any problem or defects arises during the operation of the machine. The manual will also provide the brand and type of tools that can be used, time period, life of the tools to be replaced, based on the usage and periodical inspection to be carried out. In general, manual has to provide the information right from starting of the machine, operating method and stopping the machine. In case of emergency, operator should be able to stop the machine. Let's look at the checklist of items to be checked. Good working, satisfactory status. Defective, remedial measures. Availability of machine manual. Safety guards, installation. Level of the machine. Belt and its tension, bearing sound, driving clutch and brake, exposed gears, working in all the speeds, working in all the feeds, lubrication system, coolant system, sliding part and its travel, safety and limit switches, electrical controls, proper lighting, emergency stop, alarm specialty, condition of work holding devices, condition of tool holding devices, condition of accessories and attachments, chip collection and disposal. Let's look at the equipment record. History sheet of machinery and equipment. Description of equipment. Manufacturer's address, supplier's address, order number and date, date on which received, date on which installed and placed, date of commissioning, size, weight, length, width and height, cost, motor particulars, volts, revolutions per minute, phase, volts, bearings, spares, record, belt specification, lubrication details, major repairs and overhauls carried out with dates. Let's quickly recap what we have learned so far. Inspection on machines should be done periodically for ensuring the safety of the machine operators. A record of the same should be kept. Manuals are useful for conveying the information regarding inspection. Manual gives information like safety procedure to be followed, operating procedure and the periodically maintenance required.
I hope that you have understood everything taught in this video. I will see you in another interesting and exciting videos. Thank you and goodbye until then. Hi students, today we are going to learn about the inspections of machine tools. In this video, we are going to learn about inspection of machine tools such as alignments, labeling. Let's first go through the job sequence, then move on to the skill sequence.
The objective of this video is to inspect drilling machine. such as alignment, leveling. Job sequence. Fix the table of the pillar drilling machine in mid position. Use a precise spirit level and straight edge for leveling the machine. The flatness of the table surfaces and base plate of the machine need to be checked. Job sequence. Check the runout of the internal taper of the spindle using a dial test indicator and test manually. The straightness of the pillar in two different planes needs to be checked. The squareness of the table surface in two different planes needs to be checked. Skill sequence. The machine should be leveled at two different positions, A and B. This should be done before conducting the geometrical tests. The permitted deviation is 0.03 per 300 millimeters. Check the flatness of the work table surface and the base plate if it is machined. If the machine is provided with a rotary motion, check the rotational motion of the rotating table. Check the runout of the spindle internal taper at two positions. Check the squareness of the spindle axis to the table surface and straightness of the pillar in two different planes. Check the squareness of the table surface to the vertical movement of the spindle housing in two planes. Check the squareness of the table surface to the vertical movement of the spindle head of the machines having an elevated spindle head. Lubricating the parts. Apply lubrication oil in main spindle, cam of the rotating table, gearbox and pillar daily by using oil can with oil. Let's quickly recap what we have learned so far. Level the machine to check the flatness of the table surface and base plate. Check the runout of the internal taper of the spindle. Check the straightness of the pillar and squareness of the table surface.
I hope that you have understood everything taught in this video. I will see you in another interesting and exciting videos. Thank you and goodbye until then. Hi students. Today we are going to learn about accuracy testing of machine tools. In this video, we are going to learn about accuracy testing of machine tools such as geometrical parameters. Let's first go through to the job sequence and move on to the skill sequence.
Objectives of this video are to check the level of a center lathe, to check the true running of the lathe spindle, to check the alignment of the main spindle and the tailstock spindle of a lathe, to check the parallelism of the tailstock sleeve with respect to bed ways, to perform practical test on turned component. Job sequence. The dial gauge should be fixed on the carriage. The quill of the tailstock should be projected to the maximum extent possible and lock it. Use a dial test indicator to check the quill's horizontal and vertical positions. During each measurement, clamp the quill. Place the dial plugger to contact over the free end of the quill in the vertical plane. Set the dial at 0 position. Move the carriage slowly towards the entire length of the quill. At the extreme end of the quill, note dial reading. Verify the deflection of the dial reading and compare the value with the test chart supplied. Set the dial horizontally and repeat the above procedure for checking in the horizontal plane. The test mandrel should be fixed into the tailstock spindle. To test the accuracy of the tailstock spindle in the vertical and horizontal positions, repeat the same procedure. Checking the tailstock. Insert a hollow test mandrel 300 to 500 mm long in between the centers. Make sure that the spindle bearing is at its working temperature. Fix the dial gauge. On the saddle, the plunger touching a position of the mandrel and set it to 0. The dial plunger should be set at the top of the mandrel and the saddle should be moved along the bed to the entire length of the mandrel. The reading of the dial should be observed as the saddle moves along the beds and note for variation if any. The tailstock center must be higher than the spindle center within the permissible limit. The deflection of the dial gauge reading should be verified and compared with the value of the test chart. Checking the true running of a spindle. Locate the taper shank of the test mandrel in the spindle taper. The dial gauge should be held stationary in the carriage. Its plunger contacting the mandrel near its free end and set it to 0 position. Rest the dial gauge plunger at right angles radially to the surface to be tested. The spindle should be rotated along with the mandrel slowly by hand. Observe and note the reading of the dial gauge. Move the dial gauge near the spindle nose. Rotate the spindle along with the mandrel slowly by hand and note the reading. While the spindle is slowly rotated, take readings of the dial gauge. The deflection of the dial reading should be verified and compared with the value of the test chart. Skill sequence. The objective of the skill sequence is to adjust the spirit level with the plane surface. Move the spirit level on the plane surface until the bubble is in the center of the scale. Place a straight edge against the level and clamp to the plate. Turn the level through 180 degrees and forend and place against the straight edge and note the displacement of the bubble. Adjust the while to half of the total displacement of the bubble. Repeat the above sequence until the level is turned and forend without displacement of the bubble. Level the lathe bed. Level the lathe horizontally with the help of a spirit level. Position the carriage in the middle of the bed. Keep the spirit level on the rear slide way, that is, the slide which is opposite to the operator side, longitudinally at the position A. Keep the second spirit level transversely at the position C. Take the readings of both the spirit levels. The level of the bed should be adjusted till both the spirit levels show the same reading. The sequence of operation should be repeated till both the spirit levels show the same reading in all positions A, B, C and D. Let's quickly recap. The steps include fixing a dial gauge on the carriage, checking quill alignment vertically and horizontally, confirming tailstock center alignment, and evaluating spindle true running with test mandrels. Spirit levels are used to precisely level the lathe bed through bubble displacement adjustments. We aligned the bed longitudinally and transversely based on spirit level readings.
I hope that you have understood everything taught in this video. I will see you in another interesting and exciting videos. Thank you and goodbye until then.
Hi, my name is Deepthi. Hollow punches are used to make indentions in soft materials such as leather or plastic in order to create a starting point for a cutting or drilling operation. Extractors are used to remove screws, bolts, or other fasteners that are stuck, damaged, or stripped. Drifts are used to align holes in materials such as metal plates or pipes in preparation for fastening or welding. Hammers come in various shapes and sizes and are used for striking and shaping materials. Spanners are used to tighten or loosen nuts and bolts and come in various sizes to fit different types of fasteners. Each of these tools has a specific purpose and is used in repair work to help make the necessary cuts, indentations, and fastenings. It is important to choose the right tool for the job to ensure the repair work is effective and safe. We look into the tools in this video.
At the end of this demonstration, you will be able to note the types of spanners, the types of hammers, use of extractor and punches, tools required, hollow punch, drift, extractor, hammer, cross pane hammer, straight pane hammer, single-ended spanner, double-ended spanner, Tommy bar. There are a lot of tools used in repair work. Some of the major types of tools used in fitter job are as follows: hollow punch, drift, extractor, hammer. Now, let's see each types in detail. Hollow punch. A hollow punch is a hand tool used to make a clean circular hole in soft materials such as leather, plastic, or rubber. It consists of a cylindrical shape with a hollow center and a sharp edge used to cut out a circular piece of material. The punch is placed on the material and strike with a hammer to cut the hole. Hollow punches are commonly used in leather working, upholstery, and arts and crafts. A hollow punch is a useful tool for fitters in various applications, including pipe and tube fittings. It can be used to create holes in pipes or tubes for threading or welding. Sheet metal fabrication. It can be used to create holes in sheet metal for fastening or mounting. Drift. The drift tool in a fitter refers to a tool used to adjust or align components or parts in a fitting or assembly process. It is usually a long, thin tool with a pointed or rounded end that is used to gently nudge or move the parts into the correct position. The term drift tool is commonly used in metalworking, automotive repair, and other fields where precise alignment is necessary. The primary use of a drift tool in fitter is for adjusting or aligning components or parts in a fitting or assembly process. Some common uses of drift tools in fitting include aligning holes or dowel pins. Drift tools can be used to align holes in metal plates or parts so that dowel pins or fasteners can be inserted easily. Straightening bent parts. Drift tools can be used to gently push or hammer bent parts back into the correct position. Removing or installing press-fit components. Drift tools can be used to remove or install components that are held in place by a press fit. Adjusting gears and pulleys. Drift tools can be used to adjust gears and pulleys to ensure proper alignment and smooth operation. Aligning pipes and tubes. Drift tools can be used to align pipes and tubes during installation to ensure that they are properly positioned and supported. In summary, drift tools are versatile tools that are commonly used in fitting to align and adjust components and parts to ensure precise and accurate assembly. Extractors. Extractors in a fitter refer to tools used for removing or disassembling components that are stuck or difficult to remove. They are often used to remove broken screws, bolts, pins, or other fasteners that have become lodged in a component. Extractors come in a variety of sizes and shapes and can be used with a variety of tools such as pliers, wrenches, or vices. There are several types of extractors, including spiral extractors. These have a spiral flute that is designed to grip and remove broken screws, bolts, and pins. Left-handed drill bits. These drill bits are designed to back out screws and bolts rather than cutting into them. Easy out extractors. These are similar to spiral extractors, but they have a hexagonal shape that allows them to be used with a wrench or pliers. Stud extractors. These extractors are used to remove broken studs from engine blocks or other components. Hammers and spanners. Hammers and spanners are two common tools used by fitters. Hammers. Hammers are used to strike or apply force to components during the assembly or repair process. Hammers are used for striking purpose such as straightening bent parts, setting or removing nails, or tapping components into place. Claw hammer, used for removing nails and demolition work. Ball peen hammer, used for metalworking striking purpose such as shaping and bending metal. Mallet hammer, a soft-headed hammer used for striking purpose that require a non-marring blow such as woodworking. Spanners. Spanners are tools used to tighten or loosen bolts, nuts, and other fasteners. They come in a variety of shapes and sizes and can be used to grip the heads of bolts, nuts, and other fasteners. Some spanners are adjustable, allowing them to be used with different sized fasteners, while others are designed for specific sizes and shapes. Types of spanners: single-ended spanner, double-ended spanner, Tommy bar spanner. Both hammers and spanners are essential tools for fitters as they are used in many different tasks and applications during the assembly and repair of components. They are designed to help fitters apply force and adjust fasteners with precision and accuracy, which is essential for ensuring the proper functioning of assembled components.
Let's have a recap of what we have learned today. We have learned to select the holes for repairing, use the types of spanners, use the types of hammers, use of extractor and punches. Thus, we have learned the use of hollow punches, extractor, drifts, various types of hammers and spanners for repair work. Hope you have a clear understanding on this. Do this exercise with the help of your instructor.
Hello everyone. Today's video will teach you how to erect simple machines.
Objectives: at the end of this video, you can be able to erection of lathe machine, erection of drilling machine, erection of power hacksaw machine, testing the machines after erection. Let us briefly discuss on lathe machine. A lathe machine is an equipment that uses a tool that may be fed deeply into the workpiece and travel across it to remove unwanted material from spinning workpieces in the form of chips. One of the most adaptable and frequently used machines in the entire globe is the lathe. The mother of all machines is another name for the lathe because it enables a wide range of operations. The lathe machine has evolved into a general purpose machine tool used in manufacturing and repair work. The lathe machine's numerous components include bed. The lathe machine's bed serves as the framework for mounting all of the other components. The bed is supported by large box section columns and is made of cast iron or a nickel cast iron alloy. The guiding and sliding surfaces are present and its upper surface is either scraped or grounded. The bed is made of hefty metallic slides with forced ways or vesses along their length. Cross grids provide rigid support for it. Headstock. On left side of the bed, there is a headstock. Power transmission to the various components of the lathe is the headstock's primary duty. It correctly assigns and supports the main spindle inside the bearing. Additionally, it contains a gearbox system that is required, complete with levers for changing speeds. The following items are mounted on the headstock spindle: 3-jaws chuck, 4-jaws chuck. Tailstock. Tailstock is a movable casting located opposite to the headstock on the way of the bed. The basic function of the tailstock is to support the other end of the work when being machined. To hold a tool for performing operations like drilling, reaming, taping, etc. It consists of the dead centers, the adjusting screws and the hand wheel. The body of the tailstock is adjustable on the base, which is mounted on the guideways of the bed and can be moved to and fro. Carriage. It is located between headstock and tailstock. It is used to hold and move the tool post along the bed either towards or away from the headstock. It slides on the guideways. It is also made of cast iron. It has 6 main parts: saddle, cross slide, compound rest, compound slide, tool post, apron. Saddle. It is a casting in the shape of a H that is fixed on the lathe ways and supports the cross slide that moves the tool post. Cross slide. During machining, a cross slide on the carriage enables the movement of a tool post at a right angle to the bed guideways. The feed screw moves the cross slide. Combination rest. A component that joins the cross slide and the compound slide is called compound rest. On top of the cross slide is attached the compound rest. It is manually controlled and does not get any power. Rotating the compound rest feed screw can be used to adjust the cut depth. The compound slide is securely locked with the base once it has been adjusted as necessary. Composite slide. The dovetail joint secures a compound slide to the compound rest. Angles or tapers that can't be cut by turning the headstock are cut using compound slides. Tool post. The compound slide stop is fastened to the carriage. It is used to rigidly hold the tools in the proper position. Apron. The carriage is equipped with an apron. It consists of the carriage's whole driving and controlling machinery. Feed devices that supply the carriage with automatic feed are used to secure the apron to the saddle. Chuck. It is a crucial piece of equipment that is utilized to hold and turn the workpiece. A chuck is capable of holding even the smallest bit of work. Faceplate. The faceplate can be job installed to carry out the turning operation and is fixed to the lathe spindle. Center. A center is a component of a lathe machine that supports lengthy tasks between the headstock and the tailstock during a lathe operation. A live center is a center that inserts into the headstock spindle and revolves alongside the workpiece. Feed shaft. It is constructed of high-quality alloy steel. It is positioned beneath the lead screw and extends the full length of the bed. There is a keyway where commands can be sent to move the carriage for the feed mechanism. The power feed gives the tool cross movement when it is attached. Lead screw. It is employed for cutting thread. The lead screw, which is located on the bed's bottom side and utilized to move the carriage automatically while thread cutting is there. It has Acme threads and is composed of high quality metal. Legs. Legs are utilized to support all of the machine's loads. They are anchored to the ground to stop vibration. Chip span. Chip span is placed lower side of the bed. The main function of it is to carry all chips removed by the workpiece. Hand wheel. This is the wheel that is operated by hand to move a cross-slide, carriage, tailstock and the other parts that contains a hand wheel. Speed controller. The speed controller is located on the headstock, which controls the speed of the spindle. Bull gear. It is made from cast iron. It is used for slow and fast speeds by means of a bull gear backpin and is fixed by a key on the hollow spindle. Sleeve. Sleeve fits inside tailstock, which can be moved back and forth to fit or remove dead center. Erection of lathe machine. A lathe is a machining instrument mostly used for shaping wood or metal. It operates by having the workpiece revolve around a cutting tool that is fixed. The primary function is to remove the material's undesirable positions, leaving behind a neatly shaped workpiece. Select the space for proper functioning of machines such that machines normally must be conveniently accessible. Prepare the foundation plane as per the manufacturer instruction. As per the plan, foundation can be made. The following fundamental specifications for machine foundations must be met. The foundation must be strong enough to support the superimposed loads without failing through shear or crushing. The settlements should be within the permissible limits. As much as practical, the combined center of gravity of the machine and the foundation should be in the same vertical direction as the base plane center of gravity. To prevent resonance, the foundation soil system's natural frequency should either be too high or too low compared to the machine's operational frequency. It is recommended that the natural frequency be high for low-speed devices. A machine's rotational and reciprocating components should be perfectly balanced to reduce any imbalance forces or movements. Insert the holding down bolt before the foundation sets down. According to the weight of the machine, the depth of the foundation be made. Machine may be placed in position for leveling and aligning. To ensure that floors, ceilings and other surfaces are properly horizontal, leveling is also essential. Skipping the leveling procedure results in poor quality work, leading to crooked surfaces that are highly vulnerable to earthquake damage. Before setting the foundation, a foundation bolt inserted through the holding down hole in the basic of the machine. After setting the concrete, the machine is put on the foundation bolt in floor. Align the machine perfectly horizontal position using spirit level. The spirit level is applied to certain measuring areas both in longitudinal and cross direction. Insert wedges must be driven into the gap under the machine bed. After inserting wedge, check the level using spirit level. Grouting is carried out by pouring creamy mixture of almost pure cement. After setting grouting, the wedges may be removed. The machine base is then tightly screwed to the foundation bolts. After tightening the nuts, the correct position of the machine must once more be checked by means of the spirit level. Connect the power supply to the machine with the appropriate specification of circuit breakers. Finally, do the practical test and geometrical test. Practical test. The actual test jobs are prepared on the machine and the accuracy of the work created is then checked. Geometrical test. Verifying the sizes, forms, locations and relative alignment of components are all parts of geometric testing. They cover all operations such as planeness, alignment, axis intersections, parallelism and squareness of straight lines or planar surfaces. Safety precautions. When loading, slings should be protected from sharp-edged by packing softwood. Before lifting, ensure the load is securely slung before taking the lift. When unloading, make sure that you have a firm foundation for your stack and make provision for the removal of slings without disturbing the stack. Let us discuss how to prepare a foundation plan for lathe machine. Objective. This shall help you to mark foundation layouts. Select the space for the erection of a center lathe machine. Mark points at a distance of 1 m maximum from the pillar or wall. Draw the baseline with the help of twine thread dipped in chalk powder or chalk solution. Construct the vertical baseline using 3-4-5 method as in a right angle triangle. Mark the total base area of the machine. Draw the central line of the base horizontally. Locate the position of the holes. Mount and level machine on anti-vibration pads. Objective. This shall help you to level the machine on anti-vibration pads. Lift the machine by crowbars and place wooden blocks under the machine at all the 4 corners. Select suitable anti-vibration pads depending upon the weight of the machine. Remove the leveling bolts from the metal casting. Mount anti-vibration pads under the machine. Fix leveling bolts to the metal casting through the foundation holes of the machine. Lift the machine slightly by crowbars and remove the wooden blocks from the machine. Level the machine both in longitudinal and transverse directions using a precision spirit level of accuracy 0.02 to 0.05 mm per meter. Position the carriage in the middle of the bed. Keep the spirit level on the rear slideway, that is, the slideway opposite the operator's side longitudinally at the position A. Keep the second spirit level transversely at the position C. Take the readings of both the spirit levels. Adjust the level of the bed till both the spirit levels show the same readings. Keep the spirit levels longitudinally and transversely at positions B and D. Adjust the level of the machine as required by screwing or unscrewing the leveling bolt. Finally, check the level of the machine with the spirit level. Lock the position of the machine by leveling lock nuts after completion of work. Recap.
In this video, we have learnt about the parts of a lathe machine and discussed how to prepare the foundation and erect the lathe machine. I hope after watching this video, you can be able to erect a lathe machine. Thank you for watching. Have a wonderful day.
नमस्कार, आपका फिर से स्वागत है इसी लैंग्वेज के दूसरे अध्याय में। मैं हूं आपका प्रशिक्षक कौशल किशोर शर्मा, प्रधान तकनीकी अधिकारी सीडैक पुणे। आज हम देखेंगे डेटा के प्रकार, फॉर्मेट स्पेसिफायर, साइज ऑफ ऑपरेटर, वेरिएबल, आइडेंटिफायर्स,